Now, when we do mathematical operations with measurements, we've got to make sure that our answer does not indicate a precision that's greater than that of the measurements that we actually took. Now, there are two separate rules for multiplication and division, and then for addition and subtraction. So we're going to look at multiplication and division first. When multiplying or dividing measurements, and measurements will always have sig figs, our final answer has as many sig figs as the measurement with the fewest number. So if I put these values into my calculator and I multiply them together, this is the answer that my calculator gives me, which clearly has a precision much greater than any of my original values. So the rules for addition and the rules for multiplication and division is we go back to our values and we look at how many sig figs each value has. This has 3, this has 5, and this has 2. Remember, leading zeros don't count, and trailing zeros count. Trailing zeros are zeros at the end of a number if there's a decimal point. So this is the least number of sig figs. So my answer can only have 2 sig figs. So what I do is I look at my last allowable digit, I look to the right, and if this value is 5 or more, this gets rounded up. And if it's less than 5, it stays the same. So 45 is my final answer. Now let's look at this example. Here we have division. When I divide these two values, plugging them into my calculator, this is the answer that my calculator gives me. When I go back to look at how many sig figs my measurements have, this has 4 and this has 3. Therefore, my answer can only have 3. So this is my last allowable digit, 1, 2, 3. I look to the right of my last allowable digit. This is greater than 5, so it rounds up to 0.966. And let's just review the rounding rules. They're the same as the rules you've learned in math. You only look to one digit past your last allowable digit, and if that digit is 0 to 4, we say round down. We're not really rounding down, we're just leaving that last digit as it is. And then if the digit to the right of the last allowable digit is 5 to 9, then we round that last digit up. So let's look at this. Let's round to 2 sig figs. 2.34 would round to 2.3. Here's our last allowable digit, less than 5. This goes to 2.3. If we look at this to 2 sig figs, there's our last allowable digit. That's greater than 5. 7 is greater than 5. So this rounds to 2.4. Rounding this to 2 sig figs, I look at my last allowable digit, look to the right. 4 is less than 5, so 3 remains. We don't look at any other digits. We don't care what they are. We only look to the digit directly to the right of the last allowable digit. Now let's look at larger values. Let's look at 234. If we round this to 2 sig figs, then we're going to end up with 230. It does not round to 23. When you round a value, you cannot change the magnitude of the number. So 234 rounds to 230. Now remember, we don't like to have trailing zeros without a decimal point, so it's best to express this in scientific notation, 2.3 times 10 to the 2. Let's look at 237. We want to round it to 2 sig figs. Here's our last allowable digit. We look to the right, that's greater than 5, so 237 rounds to 240. It does not round to 24. It rounds to 240. And again, we don't like to express numbers with trailing zeros without a decimal point because it leaves some questions. So we want to express it in scientific notation, just because it clarifies what's going on. And then let's look at this. If we round this to 2 sig figs, here's my last allowable significant figure. I look to the right, 4 is less than 5, so this rounds to 230. And again, we want to eliminate any ambiguity with a trailing 0 without a decimal point, so we express this at 2.3 times 10 to the 2. Now if I had put a decimal point at the end of this, in chemistry land, that would make this 0, the last 0, significant, because trailing zeros with a decimal point are significant. So that's why I cannot put a decimal point at the end of these, because I'm only allowed to have 2 significant figures. So go ahead and pause this slide and round the answer to both of these problems to the correct number of sig figs. And the first thing you want to do is look at how many significant figures the values have. This has 3, this has 2, this has 4, this has 4, and then this has 2. We have multiplication and division. We go from left to right according to our math rules, and this is what your calculator should tell you. 2 sig figs is what our answer is allowed to have, so these leading zeros don't count. Here is the last allowable digit. I look to the right, that's 5, so my 7 is going to round up. 0.068 is the answer expressed in correct significant figures. And in number 2, if we count our sig figs, 4, 3, remember that leading doesn't count, and trailing, a 0 at the end, counts if there's a decimal point. And this, of course, has 6. When we do our math left to right, our calculator tells us this. 3 is the smallest number of significant figures. There's our last allowable digit. I look to the right. That's greater than 5. So my final answer is 1.52. I've got to round my 1 up. The next voice lecture is going to talk about the rules for addition and subtraction, and they are very, very different. One of the biggest difficulties in mathematical operations with significant figures is students confusing the rules between multiplication and division and addition and subtraction. Make sure you take very, very good notes and clearly understand the difference between the rules between the two operations, and that'll save you a lot of headache come test time.